This is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today I want to discuss about some definitions and terminology of shear force and bending moment topic. So already we have discussed about the shear force and bending moment theory, and then for types of beams, and also we have solved some problems. But in this session, I want to discuss some important definitions. So definitions and terminology are very important for every topic. So before driving the equations or before solving the problems, so need to know some definitions, some identify some definitions, important definitions and terminology of shear force and bending moment. So in this session, so I will explain. So what are the main definitions of shear force and bending moment, and what are the important terminology we will see. The course outcome already you know, the student should be able to illustrate the shear force and bending moment distribution in beams for analyzing the structural behavior under various loads. So illustrate the shear force, so and then bending moment distribution in beams. The student should be able to draw the shear force and bending moment diagram after completion of this module. So already we have discussed about various beams, types of beams, and then problems also we have solved. So now, after completion of this definition and terminology, the student 100% familiar with this student, the shear force and bending moment distribution in beams. They should be able to illustrate all type of diagrams. So this is the main outcome of this module. See some important definitions and terminology. So before going to enter into the main topic, the shear force and bending moment, you should know the beam. What do you mean by beam? So a beam is a structural member used for bearing loads. It is typically used for resisting vertical loads, shear forces, and bending moments. So the beam is a structural member. It bears some type of loads. So example here, it is a beam. So it acting some loads. So it means it bears some loads, typically used for resisting vertical loads, and shear forces and bending moment. So the bending moments, UDL. So like this, different types of loads are there, but all loads it will carry. So that member is called as the type of structure member is called as beam. Now coming to the shear force, the types of beams later we will see. So what do you mean by shear force? So here one term used here, shear force and bending moment. It may be defined as the algebraic sum of all vertical forces, either to the left or to the right hand side of the section. Shear force having an upward direction to the right hand side of a section or downwards to the left of the section will be taken positive. See here, algebraic sum of all vertical forces either to the left or right of the section. So suppose here the beam is load acting here, two loads are acting here, taken section here. So what is the algebraic sum of the vertical forces here at this particular left side or right side? Okay, downwards to the left of the section will be taken positive and upward is negative. Similarly, the negative shear force will be one that as a downward direction to the right of the section or upward direction to the left of the section. So these sign convention also very important while solving the problems. In shear force diagram, that is shear SFD will tell you the variation of shear force along the length of the beam. The shear force shown here in this diagram. So the positive shear force. So there is section and this is left side and right side. So the upward is positive. Here right side downward is positive. Either in this case the shear force will be negative, downward left side one is negative, and right side section here right side force are calculating, the upward is negative. Shear force at any section of a beam is defined as the net vertical force or unbalanced vertical force. Net vertical force or unbalanced vertical force on either side of the section. It is denoted by SF, that is shear force. The shear force at any section of beam is defined as the net vertical force or unbalanced vertical force on either side of the section. So already I told you in above paragraph. So next, bending moment. Coming to the bending moment, that is BM. So it may be defined as the algebraic sum of the moments of all vertical forces either to the left or right of the section. In previous case, we are considering only loads, but here the moments. You are taking moments about A or left side or right side. The sum of the moments of all vertical forces either to the left or right of the section. So the bending moment causing concavity upwards will be taken as a negative. So in sign convention for bending moment also here important and are called as sagging bending moment. And similarly the causing convexity upwards will be taken as positive and called hogging. So one is hogging and another one is sagging. So these two bending moment are very important in this shear force and bending moment diagrams. So convexity upwards will be taken as positive and negative is hogging shown in this diagram. The bending moment will be positive in sagging case and hogging the bending moment will be negative. So we'll tell you the bending moment, the variation of bending moment throughout the length of the beam. So how it will vary in a beam, in a given beam. So the moment which tends to bend the beam in plane of load is known as bending moment. In other words, the bending moment at any section of a beam is the net or unbalanced moment due to all forces on either side of the section. It is the algebraic sum of moment due to all forces on either right or left side of the section. The effect of bending moment is to bend the element. The sign conventions, external load and shear force and bending moment. These are the three types of loads. Positive case shown in this figure. The external load is acting like this. And the UDL also acting upwards. The couple. It means all these type of loads must be positive. In this case, the load is upward and this one also upward, so negative. In this case, shear force C, upward force and one is negative, downward force positive. And like this acting forces have to take the sign convention as negative. Similarly, bending moment. And positive bending moment and a negative bending moment. Now, coming to the types of end supports. So, roller support cannot prevent translational movements in horizontal or lateral directions, and any rotational movement about prevents vertical translation. So cannot prevent the translational movements. Its reaction force is single linear force perpendicular to and away from the surface, upward and downward. So this support type is assumed to be capable of resisting normal displacement. See, I will show you the types of end supports diagrams: roller support, pinned support, and fixed support. So these are the types of end supports. So in beams, the basic terminology is one is shear force and bending moment, and then type of beam and types of supports, end supports, and types of loads. These are the very important terms. So now one by one we will see the roller support. The shown in diagram, one end is a roller support. So it can move so horizontally. There is no movement of vertical. So roller support allows thermal expansion and contraction of the span and prevents damage. Other structural members such as a pinned support. So it allows thermal expansion or contraction of the span. So the typical application of roller supports is in large bridges in civil engineering. Roller supports can be seen at one end of a bridge. And roller supports can be seen at the end of the bridge. You can see this type of end supports, roller support. So mainly advantage of this support is it prevents the damage due to thermal expansion and contraction. Next, pinned support. Pinned support attaches the only web of a beam to a girder called a shear connection. So the support can exert a force on a member acting in any direction and prevent translational movements or relative displacement of the member ends in all directions but cannot prevent any rotational movement. It cannot prevent the rotational movement. It prevents only translational movement. See in this diagram shown. So at this edges, end point is pinned. So its reaction forces a single linear force of unknown direction and horizontal and vertical forces which are components of the single force are known as unknown direction. So the single force of unknown direction. So next, pinned supports is just like a human elbow. So it can be extended and flexed. But you cannot move your forearm left to right. Translation. So one benefit of pinned supports is not having internal movement forces and only their axial force playing a big role in designing them. Just like a human elbow, it can be extended and flexed on rotation. So next is fixed support. Rigid or fixed supports maintain the angular relationship between the joined elements and provide both force and movement resistance. So it is the angular relationship between the joined elements and provide the both force and movement resistance. So it exerts forces acting in any direction and prevents all translational movements. So all translational movements means horizontal and vertical, as well as rotational movement of a member. See fixed support. These supports reaction forces are horizontal and vertical components of a linear resultant. It is a rigid type of support. So the fixed support application is beneficial when we can only use in single support. People must widely use in this type of joint support as the only support for a cantilever beam. So in cantilever beam, types of beams already, so we will discuss later. So one end is free, other end is fixed. It is cantilever beam. So at the free end, load will be at fixed support. So they are common in beam to column. Connection of movement resisting steel frames and beams, columns and slab connections in concrete frames. See the fixed support. Shown here, and one end. This is a cantilever beam. So mostly used in these beams only. Now coming to the types of beams. We have discussed beam definition, and then important terminology related to beams, and also have discussed these types of supports. So the terminology, the roller support, pinned support, types of end supports, fixed support. Clear? Now we will see the types of beams. The simply supported beam, cantilever beam, overhanging beam, and continuous beam, and fixed beam. So according to the type of beam, how to solve the problem, and also how to draw the shear force and bending moment diagrams. It may vary. So that is beam to beam. First we will see the simply supported beam. Define the simply supported beam. So how do you define? A simply supported beam is a type of beam, so why? Because it is a structural member, it carries various loads. But it has pinned support at one end and roller support at the other end. One is fixed support, pinned support, like roller support, and another one is fixed. The period we have discussed the types of end supports. So depending on the load applied, it undergoes shearing and bending. It is the one of the simplest structural elements in existence. So I will show you diagram. See, a simply supported beam is a type of beam that has pinned support at one end and roller support at the other end. This is the roller support. This is pinned support. So now cantilever beam. So how do you define the cantilever beam? So the cantilever beams, it is a structural member of which one end is fixed and another end is free. Already I told you in earlier. This is one of the famous type of beam used in trusses, bridges, and other structural members in bridges and stresses in truss problems. And this beam carry load over the span which undergoes both shear stress and bending moment. So I will show you diagram. This is fixed support and free end. This type of beam is called as cantilever beam. So length L. So you can apply the load at its free end, at its middle. Next, overhanging beam. So the overhanging beam is combination of simply supported beam and cantilever beam. So one or both end overhang of this beam. Some portion of the beam will be overhanged. This beam is supported by roller support between two ends. This type of beam has heritage properties of cantilever and simply supported beam. So I will show you the overhanging beam. See, one end is roller support, other end is pinned. That comes under simply supported, and one more roller support also there, and the remaining, this one is overhanged. So overhanged portion of the length. So up to here, this is simply supported beam, but this one is overhanging. So this type of beams are called overhanging beams. So in these beams, the combination of simply supported beam and cantilever beam. So next one is continuous beam. This beam is similar to the simply supported beam, except more than two supports are used on it. One end of it is supported by hinged support, and other one is roller support. So not fixed and not pinned. So hinged support. So like this. So hinged, you can draw like this also. So roller supports, two supports are used on it. So one or more supports are used between these beams. So it is used in long concrete bridges, where length of the bridge too large. There these type of beams are used, continuous beams. So I will show you in this diagram. So roller supports and hinged support. Next, fixed beam. So this beam is fixed from both ends. It does not allow any vertical movement. There is no vertical movement. It is only under shear stress and no movement produces in this beam. It is used in trusses and other structures. This one also fixed and this one also fixed. To both sides are rested. There is no motion. There is no translation. Not allow vertical movement. And rotation also. Rotation also not possible. Generally, these type of beams are used in trusses and other structures. So that the beam is usually horizontal member, and the load which will be acting over the beam will be usually vertical loads. There are following types of loads as mentioned here, and we will discuss each type of load. So now the beams already we have discussed, and supports also we have discussed, and then shear force and bending moment. We have discussed those points. Now, a beam is usually a horizontal member and carries some loads. So loads also, different types of loads are there. So now we will see the types of loads acting over the beam will be usually vertical loads. So many types of loads are there. One is point load or concentrated load. So point load or concentrated load, point load. Uniformly distributed load, it is UDL. Uniformly varying load. So like this, 0 to maximum. It increase. So varying load, these are the three types of loads will be acting on beams. So now one by one we will see how do you define the point load or concentrated load. The point load or concentrated load, as name suggests, acts at a point on the beam. Suppose take a cantilever beam. At this point the load is acting. The point with distance L. So if you will see, practically point load or concentrated load also distributed over a small area, but we can consider such type of loading as point loading, and such type of loads could be considered as point load or concentrated load, concentrated at this area only. So it occupies some area here. See, the following figure displayed here indicates the beam AB of length L, given the beam is simply supported beam. So the AB of length L will be loaded with point load W at the mid of the beam. So the load W will be considered here as the point load. So entire length, the load is acting at its center. Suppose here acting another load with distance L1. So the load will be considered as a point load only. Next, what is this uniformly distributed load? So you can say, you can write uniformly distributed load, UDL. So uniformly distributed load is the load which will be distributed over the length of the beam in such a way that rate of loading will be uniform throughout the distribution length of the beam. So one is here roller support, another end is pinned. So the type of load is here UDL. So W Newton per meter. So this type of load will be distributed over the length of the beam. So entire length of the beam it will be occupied. So the loading will be uniform throughout the distribution length of the beam. While solving problem, you must convert this uniformly distributed load into point load. So the point load is W, the unit load W Newton per meter. So how much load acting per meter, the Newton per meter. So what is the length here? W into L. You must multiply with the total length. It gives concentrated load. So the uniform distributed also expressed as UDL. During determination of the total load, so already here written, the totally uniformly distributed will be converted to a point load by multiplying the rate of loading, that is W, which is the span of distribution. So W multiply with L. W into L. So L end will be acting over the midpoint of the lengthen of the uniformly load distribution. See here, consider on figure here simply supported beam. A beam of length L is loaded with uniformly distributed load. and the rate of loading is W Newton per meter. The total uniformly distributed load P is equal to W into L. P or W, you can take any notation shown in this UDL. So load will be distributed throughout the span of the beam. Uniformly varying load. So the uniformly varying load which will be distributed over the length of the beam in such a way that the rate of loading will not be uniform but also vary from point to point throughout the distribution length of the beam. So uniformly varying load is also termed as triangle load. Here I will show you the figure. The beam AB length of L is loaded with uniformly varying load. The AB length loaded with a variable load, that is UDL. So you can see from the figure that load is 0 at one end and increases uniformly to the other end. See, you can see here the load is 0 and uniformly increasing. In previous case, in this, so not vary, so it is a constant. So that's why uniform distributed load and the rate of loading is W from one end to other end. But in this, not like that. So that load is 0 at one end and increases uniformly to the other end. So during determination of the total load, we will determine the area of the triangle and the result. So the area of the triangle will be total load, and this total load will be assumed to act at the center of gravity of the triangle. Center of gravity of the triangle. So triangle is ABC. So what is the center of gravity? Determine the area of the triangle and the result. The area of the triangle will be total load, and this total load will be assumed as act at center of gravity of the triangle. Thus total load P is equal to W into, or W is equal to W into L by 2. So half of the length. So uniformly varying load. So the total load assumed to act at center of gravity of the triangle. So you can write W into. So in this the uniformly varying load converted into a point load. Point load or concentrated load multiplied with half of the distance. But in this UDL case, point load W is W into L. Entire load will be multiplied. So these are the main types of loads. So that in this definition terminology related to the shear force and bending moment, we have discussed about various beams and various types of loads and various types of end supports, and then shear force and bending moment, and then types of loads. So if you don't know this terminology and definition, you can't solve the problems. You can't understand. So which type of beam is called as simply supported beam? So how do you define the overhanging beam? And what are the supports? How many types of supports are there? Roller support, finned support, and fixed support. And types of loads also: point load, and then uniformly distributed load UDL, and then variable loads. So all problems related to the shear force and bending moment revolve around this terminology. So that's why, so these terms and definitions and terminology session is very, very important. So that's why in this session I have covered some definitions and important definitions and terminology I have covered. If any missing, you can refer any textbook. Now you can able to solve the problems, and you can able to give able to answer the following definitions and terminology. Clear? So these are the references I have taken. S. Ramamurthy and strength of material, the title of the book, and Dhanpati Rai Publishing Company, and another other R.K. Rajwood, the strength of material, and R.K. Bansal, the title of book is Textbook of Strength of Material. R.S. Kurmi and Gupta, title Strength of Material. So take any latest edition or previous edition also, no problem, for further more clarification. So these are the references I have taken for this PPT, the definition and terminology PPT. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.